Hi, welcome to Algebra 2 Common Core. Today we're going to take a look at summing up the terms in an arithmetic sequence. This is going to be called an arithmetic series. So let's look at exercise number 1, where we want to find the sum of the first 100 positive integers. Let's list those numbers down. So we know that that's going to be the sum of 1 plus 2 plus 3 plus 4 plus 5. And of course, I'm going to continue on until I get 96, 97, 98, 99, and 100 as my last term that's going to get added together. When I look at this sequence, before I add them together, just the numbers all listed down, turns out to be an arithmetic sequence. I can tell that because the d value is equal to 1. I just keep adding 1 to get the next term. There are altogether 100 terms in this sequence. So we're going to see a new notation today. S of 100, so S with a subscript of 100 means the sum of the first 100 terms of the sequence. Now, sometimes in math, when we take a look at this sum, we think of it as a rainbow. If you look at the numbers, when I connect the first number with the last number, I see that the total is 101. I can do the same thing with the second number and the second last number. And if you look carefully, you see that the sum is still 101. 3 plus 98, 101. 4 plus 97, 101. 5 plus 96, also 101. Now, if I count up how many times I'm summing 101 together, I see that there have to be 50 pairs of these numbers. So the total sum of the first 100 numbers in this series would be 101 times 50, which gives me a total of 5,050. So if you haven't thought about this kind of sum before, let's think about where that total comes from and why we have the number of terms that we do. This 50, the 50 that represented the number of pairs, really is the number of terms in the sequence divided by 2. That's what tells me I have pairs. The 101 just turned out to be the same as the first term plus the nth term, or sometimes we call it the last term in the sequence. So let's go ahead and put this in our definition box. A series is just the sum of the terms of a sequence. So when we look at our formula, Sn equals n times a1 plus an divided by 2. We know that A1 stands for the first term of the sequence, and we know that AN stands for the nth term. In terms of our sum, it's the last term that we're adding together. Sn stands for the sum of the first n terms, and n stands for the number of terms. Now, sometimes I like to think of this formula in this way. Sn is equal to n divided by 2, because that tells me my number of pairs, multiplied by that rainbow sum, a1 plus an. As long as I have an arithmetic sequence, that sum, a1 plus an, is constant when I look at any pair of terms that form the rainbow. Let's do exercise 2, in which we're going to find the sum for each arithmetic series that's described below. So I've got 4 different scenarios here. In part A, the sum of the 16 terms given by, and I've got those numbers all added together. Now when I look at those numbers, I notice that yes, I do have an arithmetic sequence. It's called a series because I want to add it together now. And the d value is equal to 4 because to get any term, I have to add 4 to the previous term. So let's make our sum of the first 16 terms, because it said go with 16, so n must be 16. Substituting into my formula, I'm going to say 16 divided by 2 tells me how many pairs I'm going to have. And then I want my first term, negative 10, plus my last term, 50. Now the calculation even becomes pretty easy without your calculator if you think of it in this way. 16 divided by 2 is 8. Negative 10 plus 50 gives me 40. And 8 times 40 tells me that the total must be 320. So when I add together all the terms in that sequence, all 16 of them, the arithmetic series is that sum, so it's 320. Let's look at part B. In this case, I know that my first term is equal to negative 8. I've got that the common difference is equal to 6, and I know that there are 20 terms, so n must be 20. Now clearly in our formula, what we are missing is the last term, or the 20th term this time. So I'm going to find a20. Remember 2 lessons ago where we had our formula, so a20 would be equal to a1 plus n minus 1 multiplied by d. So I'll have to first of all calculate a20 before I can do my sum formula. So negative 8 plus, since n is 20, 20 minus 1 is 19, multiply that by my d value of 6. So when I put all that together, a20 turns out to be 106. Now that's just the 20th term. That doesn't give me my sum. So now I want to do the sum of the first 20 terms, S20. There are 20 terms, so I'm going to take 20 and divide it by 2. And then I'm going to multiply by the rainbow sum. First term, negative 8. Last term, 106. That really tells me that I'm doing 10 multiplied by 98. So the total here, 980. That's a lot easier than listing them all down and then adding together. Plus, most of the time you're going to have to show your work, so you're going to have to show that sum formula. Let's look at part C. We know the last term, a12, is equal to negative 29, and the d value is equal to negative 3. So for this one, we know that n is equal to 12, and this time we have the last term, a12, as negative 29. We're missing a 1 this time. So using the same formula for the term of an arithmetic sequence, a12 is equal to a1 plus n minus 1 times d. We know a12, that's negative 29. We don't know a1, so let's leave that in our equation. Since n is 12, n minus 1 is 11, and d is negative 3. So negative 29 is equal to a1 minus 33. So that tells me that a1 must be equal to 4. Now we are able to go ahead and find S12 by saying, oh, there's 12 terms, so divide that by 2. That gives us how many pairs? Times the rainbow sum, 4 plus negative 29. Again, this calculation becomes really easy even without our calculator. 6 times negative 25 is, of course, equal to negative 150. So my total of all of those terms in that arithmetic series is negative 150. Let's go to part D. We've got another sum where we know that A1 is equal to 5 and AN is equal to 77. If we look carefully, we notice that the D value is 3. But what we're missing this time is our N. So again, we have to keep relying on that formula, AN equals A1 plus N minus 1 times D. And we know everything except for N. So 77 is equal to 5 plus N minus 1 multiplied by 3. I'm going to subtract 5 from both sides, so that gives me 72 is equal to 3N minus 3, distributing the 3 there. So now I get the 3N equals 75, so N must be equal to 25. Now let's use our formula for the sum of the first 25 terms. That's going to be 25 divided by 2, multiplied by the first term 5, plus the last term 77. Sometimes I like to switch where I put the divided by 2 because I've got an odd number here. So I can also write this as 25 times, 82 divided by 2, which is 41. So when I multiply 41 times 25, I'm getting an answer of 1025. So you can see through these 4 examples a lot of different scenarios, but in all cases we could find the sum of the first n terms using our sum formula, as long as we have an arithmetic series. Now let's take a look at what happens when we combine our sigma idea from the last lesson with our arithmetic series idea, because sigma really just means I'm adding my terms together. So first of all, it's going to be important for us to figure out what our terms are, how many terms I have, and make sure that I have arithmetic. So I'm going to start with k equaling 1. When k is 1, I see that I have 2 times 1 plus 3, so my term is 5. When k is 2, I'm putting 2 in for k, so 2 times 2 is 4 plus 3 is 7. When k is 3, 2 times 3 is 6 plus 3 is 9. Now let's go one more here. K is 4. So when k is 4, 2 times 4 plus 3 gives me 11. And I can see basically I'm adding up all of my odd numbers starting with 5. Now where am I going to stop? K is equal to 200 is my last value of k. So 2 times 200 is 400 plus 3 gives me 403. So that's the last term. I need that first term and last term to get the total. So I'm taking the sum of 200 terms, and that's going to be equal to 200 n divided by 2 multiplied by the first term 5 plus the last term 403. This is a nice easy one to do without my calculator. 100 times 408 is giving me an answer of 408 with 2 zeros on the end. So 40,800 would be that actual sum. So this sigma represents the answer 40,800. Let's try this application problem together. Kirk has set up a college savings account for his son Maxwell. If Kirk deposits $100 per month in an account, increasing the amount he deposits by $10 each month, then how much will be in the account after 10 years? So let's get a feel for what's going on each month. So I'm going to say the month, in the first month, he's depositing $100. But then in month number 2, he increases the amount he deposits by $10 each month. So now in month number 2, $110. In month number 3, he's going to deposit $120. In month number 4, he's going to deposit $130. Well, we want to know what happens after 10 years. So we see that this is an arithmetic sequence with our value of D being equal to 10. Now, since we want 10 years and he's going by month, we know that we have to find the 120th term so that he can deposit for 10 years, 12 months each year. His first value was 100, and we're going to add on n minus 1, which is 119, times 10, so that we can get that last term, the 120th term. So when I do that, it turns out that in the last month, he's going to deposit $12.90. So we're going to say plus ... So each of these gets added together because I've got a major sum here, plus $12.90 at the end. So we're actually doing the sum of 120 months. This sum will just be equal to 120 divided by 2, multiplied by my rainbow sum, first term plus last term. So this gives me 60 multiplied by 1,390. So my answer for how much money he'll have in the account, wow, Maxwell is going to have a lot of money after 10 years, $83,400. And notice that the most that Kirk has to deposit in 1 month is $12.90. That's quite a sum. Now what I'd like you to do is try the 3 U-Try-Its that are in your notes on page 8, and then come back and check with me, and I'll go over each one individually. Welcome back. Did you get a good feel for using your new formula for an arithmetic series? In example number 1, we had to first of all find the 32nd term. So I used the formula AN equals A1 plus n minus 1 times D. So A32 turned out to be 114. Then when I plugged all of those numbers into my sum formula, n divided by 2, 32 divided by 2 is 16. I added the first term and the last term. That's the last term that I just found over here. So 16 times 104 gave me a total of 1,664. For example number 2, I have to take a look at what each term is as I start with k equaling 1. So when k is 1, the first term is 3. When k is 2, that means 4 times 2 minus 1, which is 7. When k is 3, 4 times 3 minus 1 is 11. And so on until I get to the 80th value of k. So 4 times 80 minus 1 is 319. Now I have all my information to be able to use my sum formula. So I take the number of terms and divide by 2, 40. 3 plus 319, that's the first term plus the last term. So 40 multiplied by 322 gave me 12,880. For U-Try-It number 3, I've got the first term, I've got the last term. I know that the D is 3, but I don't know how many terms there are. So I had to once again use my formula AN equals A1 plus n minus 1 times D. Are you seeing how many times we use that formula with arithmetic sequences and series? Put 83 in for the AN, put -7 in for A1, and put 3 in for D. That will allow us to find n in the equation. Add 3 to both sides. I'm ending up with 3n equals 93, so n is equal to 31. Now I can go ahead and find the sum of the first 31 terms by saying 31 divided by 2 times the first term plus the last term. Here's another instance where I take that divided by 2 and I put it underneath this sum because 31 was odd, so it just makes my calculations a little bit easier. So 76 divided by 2 gives me 38. So 31 times 38 gives me a total of 1,178. Thanks for practicing with arithmetic series today. Get used to the formula. However, this is one formula that is given to you on your Algebra 2 Regents reference sheet. So the sum formula is not one that you have to memorize, but definitely know how to use it. Have a great night, and we'll see you tomorrow.